Okay, so we're multiplying x plus 2 times x minus 3. And our first step was to multiply x times x. We're using the distributive property, and we're keeping up with it with a method called FOIL. So first times first was x times x, and it gave me x squared. Outside times outside, that's what the O stands for, is outer. So x times negative 3 is negative 3x. Inside times inside is what my I stands for. That would be the 2 and the x, so it's going to be plus 2x. And then L stands for last times last, so that is 2 times negative 3, which is negative 6. And then we combine like terms. Like terms means that the variables have to be identical all the way down to their exponents. So the only two that are like are the negative 3x and the 2x. And when I put those together, I get negative 1x. So this answer is x squared minus 1x minus 6. Okay, problem number 3. We're going to start off with first times first. This is x squared times x. What do we get? X cubed. We get x cubed. If you want to think about them as having ones out front and 1 times 1 is 1, that's fine. You're adding the exponents. You multiply the coefficients, you multiply the big numbers, but you add the exponents. So that's first times first. Now we're going to do outside times outside. That would be 1x squared times negative 4, negative 4x squared. And then we're ready to do inside times inside. So that's 2 times 1x, which is 2x. And then we do last times last, which is 2 times negative 4, negative 8. Now look closely. Are there any items in this problem that match and can be added together? Do they have identical exponents? They have to have x to the identical exponent. No. So there's nothing else I can do to this one. Not at this level. When I can multiply them, but when I'm adding, all the variable parts have to be perfectly identical. Okay? Number 4. Let's start here. Now think about that as having a 1 out front. So I do first times first. 1x times 2x. So you multiply the 1 and the 2. This is 2. And when you multiply x times x, it's going to be x squared. Okay? There's still a little exponent on both of those, and you have to add them together when you multiply those terms. Well, every time we multiply x to the first times x to the first, it becomes x squared. When we multiply x's together, we add their exponents. Okay? Next, we're going to do outside times outside, and that's 1x times 3. What do we get? 3x. And then we do inside times inside, and what is that? Yes, it's 14x. And then we do last times last, 21. Look closely. Do you have any items that their variable parts are identical? The 3 and the 14, are they both positive? Then when we add them together, what do we get? Okay. Now, I'm going to add in one more problem because I don't want to leave this and you think that every single problem looks exactly the same. So number 5 is going to be x plus 7 times x squared plus 2x plus 3. What makes this one different? There's 3. The FOIL won't work here, but the distributive property concept always works no matter how many terms you need. FOIL is just associated when you have 2 times 2. They're called binomials times binomials, okay? That's when FOIL will be talked about. But the process is the same. You're going to take x and you're going to multiply it by each member of this second parenthesis. So let's do this piece by piece. What's x times x squared? X cubed. And then x times 2x is 2x squared. Everybody okay with that? And then x times 3, 3x. Any questions? Okay, now I'm going to move to the 7. Multiply it by each member. What's 7 times x squared? Okay, 7 times 2x. Okay, 7 times 3, 21. Now go back. Do you have any items that need to be combined? So let's take it piece by piece. First, I have x cubed. Does anything else in there have an x cubed term? No, so you just write x cubed. Then I have 2x squared and 7x squared. So add them together, 9x squared. Don't do anything with your variable parts. They're just markers that say, hey, put these two things together. Then 3x and 14x make 17x, and then 21. Okay, how do y'all feel about this new little skill? We're going to practice it, but I got to